Okay, so solid to liquid is melting, liquid to gas is boiling or evaporation, solid to gas is sublimation. Okay, this one you need to provide heat. Okay, the reverse is cooling process. Cooling process is you remove heat. That's why you put things, water, you want to freeze it, you put in the freezer. So the freezer will remove the heat from the water. Okay, so the substance actually lose the heat, okay, to the surrounding during cooling process. So gas to liquid is called condensation. Liquid to solid is called freezing. Okay, gas to solid have a name for it called deposition, but this one is not even O-level syllabus, so I don't want to confuse you by writing up. So that one not necessarily need to know. Okay, so the name after you know, the second part you have to know is how to sketch the heating curve and cooling curve. Okay, heating curve means when they ask you to sketch the temperature change with time from a low to a high temperature. Take note, a lot of students always make this kind of mistake. Okay, heating curve is from low to high temperature. Cooling curve is from high to low temperature. So if the question asks you to, for example, to sketch, right, the curve for water at 120 degrees Celsius to -5 degrees Celsius. Okay, that means you're asking you to sketch a cooling curve. Cooling curve is opposite direction. Okay, so don't go and sketch a heating curve if they ask you from a high to low temperature. Okay, similarly, if they ask you to sketch from a low to high temperature, don't sketch cooling curve, sketch heating curve. But usually the error is for cooling curve because students always forget, right, to check the question carefully. If they ask for high to low temperature, a lot of students still draw this one, then it will be wrong. Okay, so be careful. Okay, then when you sketch the curve, take note, axis labeling is important. Don't forget to label axis. So this is temperature in degrees Celsius against time in minutes. Okay, then initially if it's solid, then you heat, then the solid temperature will rise. Okay, when you reach the melting point, the temperature will remain constant. So this is one thing you have to take note. During state change, the temperature remain constant. Why temperature remain constant? The reason to write, you have to know also, is the energy absorbed okay, because the energy absorbed is used to overcome the force of attraction. Right? Remember, from solid to liquid, right? The force of attraction, although are both strong, but solid force of attraction are weaker than liquid force of attraction are weaker than solid. So you have to overcome the strong force of attraction in solid, then the particle can move out of the fixed position, then able to slide one another. Okay, so when the energy is absorbed to do this, the temperature remains constant. Okay, because in reality, temperature is actually what? It's actually a function of speed of particles. So when you heat the solid, what happens is the particle solid vibrate faster and faster. So when the particle vibrate faster and faster, right, the speed increase, the temperature increase. But there will be a point when the solid particle vibrate to a certain point, it cannot vibrate any more faster. Right, without turning to solid, it cannot, without turning to liquid, it cannot vibrate any more faster. So that speed during the melting process will remain constant. It cannot vibrate any more faster, right? So all the heat energy that continue to absorb will go to the force of attraction to overcome it first. Then the particle can move out of the fixed position, then they can slide, then they can move faster when they slide, right? Then after all become liquid, when continue to heat, then the liquid particle will move faster and faster, right? Then the temperature will rise. Same thing when you reach the boiling point, the liquid particle speed is maximum already, so it cannot move any faster, right? So if you want the liquid to move faster, you have to become gaseous, right? So that's the boiling process. So same thing, all the energy that is gained during boiling will be used to overcome the force of attraction inside the liquid particles, right? So they can break free and become gas, go far apart and move even faster as gas. Okay, so same thing during boiling, temperature remain constant until all the liquid become gas. Then when you continue to heat the gas, then the gas temperature rise. Okay, so technically speaking, if you have all the state change, solid to liquid to gas, you have two horizontal lines. Take note, cannot have more than two. Okay, so during the horizontal line melting, you will have coexistence of solid and liquid state. Okay, during boiling, you will have coexistence of liquid and gaseous state. So the second thing to take note is during state change, you have coexistence of two states. So if they ask you at melting point, what's the state? Remember, don't write solid, don't write liquid. It's solid and liquid. Like example, if it's water, they ask you water at 0 degrees Celsius, what is the state? Okay, don't write liquid, don't write solid. It's solid and liquid mixture. Okay, because remember the solid melt, right? Then all melt already, then the temperature can rise. So during the melting, you have two states. Similarly, during boiling, you have liquid and gaseous state. Not just liquid, not just gas. Mixture of liquid and gas. So like water, if they ask you H2O, water at 100 degrees Celsius, what's the state? Then it's liquid and gaseous state. Not just liquid, not just gas. Okay, if it's below melting point, then it's solid. Between melting and boiling point is liquid. Above boiling point, then it's gas. Can? Okay, so this thing you have to take note. Okay, and when you draw, of course, when you sketch the curve, melting and boiling point value must stay in. Okay, that means you must write the value. Okay, I write here melting and boiling point is general, but you must write down the values. Like if it's water, then 0 here, 100 here. Then the starting temperature and any temperature they give you must also write inside. Okay, if they say like -5 degrees Celsius for water to 105 degrees Celsius, then the starting temperature you must write -5, end temperature is 105. Okay, so that is the sketching of the curve. The last part of the state transition you have to know is how to determine states of matter. Usually for this one is they can give you melting and boiling point, ask you what's the state at separate temperature, or vice versa. Okay, then you have to know, but it's the same idea. So for this kind of question, how to solve? Okay, especially for negative temperature, because a lot of students usually make error with negative temperature. For this kind of question, if you cannot see, you can actually use what we call a temperature scale. Okay, like this. Okay, so for example, X melting point is -100. So here we melting point, melting point. So -100 degrees Celsius. Okay, if the substance temperature is below melting point, it will be solid. Between melting and boiling point will be liquid. Above boiling point will be gas. That's how it works. Okay, below melting point, solid. Between melting and boiling point, liquid. Above boiling point, gas. Boiling point here is -51 degrees Celsius. So now they ask you what's the state at -50. Then you see where is -50. -51 is here, 100 is here. Of course, 50 is above, right? So -50 is here. So it's what? Gaseous state. So this is gas. -49 is where? Okay, you can see is, should not write -49. Okay, change the value. Okay, let's say -60 degrees Celsius. Okay, -60 degrees Celsius is where? So 51, 100, right? So -60 will be between -60 degrees Celsius. So it's liquid state. So this one will be liquid state. Okay, then -101 is where? -101, you can see 51, 60, 100. So 101, of course, is below, so -101. So -101 is what? Solid state. So this is solid state. Okay, that's how you deduce using this temperature curve. Okay, try not to mentally determine. Sometimes because negative temperature, a lot of students always make mistake. Okay, positive temperature not so much of issue. Okay, can? Right. Ready? Can you hear me? Come it's so late. Okay. So, Colin, any question?
No.
Okay, yeah, can. So if you look through, if no question, you can try the worksheets that I've given you. Same thing, answer attached. So after you try the worksheet, you can try answer. Then any question can ask. Okay, same thing, you can type the question. All of you the same as last week. You can type the question inside the chat box. Okay, then I will just answer. Really, can you hear me? I cannot see your mic. Okay, so now let's look through. Okay, King Kai, you have any questions?
Yeah. Question 4A.
For which worksheet?
Worksheet 4 for heat.
Worksheet 4 for heat. Open up your file first. Remember, you can type your question there. So just okay, question 4 for heat. Which one following is not a good insulator of heat? Not a good insulator means what? Good conductor, right?
No, it's the structured question.
Oh, structure. Okay, structure question 1. Question 1. King Kai, 1 or 4?
4A.
4A. Okay, so the temperature rise, what is the objective of placing the right bulb inside a vacuum bell jar? Okay, so what it means is here, the thermometer here, the temperature will rise, although the bulb is put inside the vacuum flask. So this one is to what? To show that the radiation can flow through vacuum, because remember, radiation don't need matter, don't need solid liquid gas. So even vacuum heat can be transferred by radiation.
Okay.
Correct? So this one is to show that heat can actually be transferred. So that's why the thermometer also rise, because heat can be transferred by radiation even through vacuum.
Teacher.
Yes.
For fossil fuel, the MCQ I all like not very sure there.
MCQ? Which you got? Okay, let me see. Worksheet 1 is it?
No, for worksheet 2.
Worksheet 2, okay. So which one?
Cause like why like question 1 to 5 like I don't understand.
Methane is used as fuel. So what property is essential? Fuel means what? To burn to produce heat, right? So give out heat is called exothermic reaction. Remember?
Oh.
So if something is used as fuel, it must burn to produce heat. So it must burn exothermically. That's one. Then the second one is which of the following is not made from crude oil? Margarine.
Now what's margarine?
Margarine, the vegetable, the you spread on bread one.
Oh.
Butter and
so
margarine.
It's food lah.
Yeah, correct.
It's food lah.
So of course it's not from crude oil. You cannot eat from crude oil. Okay, then question 3. Remember we mentioned fractional distillation, the top is always lower boiling point than the bottom. Correct? So X has higher.
It burns more easily.
Yeah, correct. So X will burn more easily than Y lah. Yes lah. Then X has higher boiling point than Y, of course wrong lah.
Oh.
Right.
Okay.
Okay, then question 4. Oh, okay. Question 4 here is this one you may not learn yet. Okay, this one is okay. This one if you skip is good. This one linked to a bit of organic chemistry. So X is actually your hydrogen gas, because the hydrocarbon, when you do something called cracking, you can actually get hydrogen gas or some alkene or alkane, so called. Okay, but you haven't learned that, so don't want to confuse you. Never learned alkane, right?
No.
Okay, so that one is okay.
We only do nutrient cycle, then we move on to forces and pressure.
Oh, okay. Can then I upload for you some force and pressure worksheet for you to do. That time you did already, right? You did?
Last year, yeah.
Okay, so I think I give you some worksheet to try first. You have the notes, right? Still?
Yeah.
Okay, then maybe I give you some worksheet to revise for the forces. Same. Hold on, I have to download first.
Because I don't think we're doing fossil fuel this year. Because my teacher that time tell me it's just like ask whether one additional info about Set 3.
Okay. Can then because you never tell me how you know everything you tell me or your.
No, because that one is last week.
Last week you can WhatsApp me also. What? Never mind. So anyway, next week everybody have to do home tuition. I give you a worksheet 1 to try first. You have done before already, but I think maybe forget already. So try again.
Okay.
Hold on, I put inside your folder first. Okay, I put inside your folder already.
The Google Drive.
Okay. Hey, ready? Why you're so late on?
Wait, teacher, I don't think I see it.
I just put inside in the folder.
Is it the
False
same
impression.
link?
Yeah, it's the same folder.
Oh.
You have to refresh a bit. Okay, ready? You're still at the electricity, right?
Yeah.
Okay. Hey, why you come in so late? 10:30 start class.
I'll here at 11.
Here 11 and then make some noise. But 10:30 start, I try to be on time because
I know,
for online tuition, when we start teaching, later it's very hard to go back already because got a few other
I know, because it's very painful.
Okay, so for the you're doing the calculation already, your school?
Not yet.
Oh, not yet calculation, still at the introduction of those things.
Yeah.
Okay, so first. Okay, just now I go through for electricity, I just go through with a couple of them on the calculation for current and voltage for series and parallel circuit. So I just write down first and quickly just run through with you. They can try it out. Okay, for series circuit, okay, this one is for multiple resistor, same thing. Okay, it's not for one. So usually they'll give you the battery's voltage, then you have to know how to calculate the current, right? Total current or the current that goes through each resistor, right? Or the voltage for each resistor. Okay, the key thing now is you imagine the current is like people, right? So the total number of people come out from battery, right? All have to climb the mountain. Resistor is like mountain, okay? So all have to climb the first mountain, second mountain, and third mountain. So therefore, the current I1 equal to I2 equal to I3 is equal to I total, right? Because all the 10 people come out, all the 10 people that climb the first mountain, so I1 is 10, right? 10 people. I2 also 10 people, I3 also 10 people, that kind of idea. Then voltage relationship is, voltage is like energy. So voltage is actually V1 plus V2 plus V3 equal to V total, right? How to interpret energy? Very simple. Imagine you are one of the people that come out from battery. The battery gives you 6 volt energy. So you will have to use the 6 volt. Okay, you have to use the 6 volt to actually climb all the 3 mountains. Right? So the V1 plus V2 plus V3, the 3 energy you need to climb the 3 mountains, all add up is equal to the total energy the battery gives you. Okay, that's the idea. So these two relationships, once you establish, then how do we calculate all the I's? Very simple. Whether they ask you I1 or I2 or I3 is to find I total. So how to find I total? Basic formula, I equal to V over I. So you want to find I total, you want to find I is V over R. Manipulation, remember, cross multiply. So I total equal to what? V total over R total. You want total, everything total. So V total is 6 volt. R total is 1 ohm plus 2 ohm plus 3 ohm. Remember, for series circuit, effective resistance or total resistance, just add up. Okay, so you will get 6 divided by 6. So it's 1 ampere. Then this 1 ampere is also equal to I1, equal to I2, equal to I3. Because remember, the same people have to climb all the 3 mountains. Okay, then how do you find V? V equal to what? Ri, Raffles Institute. So if they ask for V1, then R1 times I1. So R1 is what? 1 ohm from here. Okay, I1 is what? 1 ampere, because I1 equal to I total. So you get 1 volt. Okay, then if they ask for V2, R2 times I2, same thing. So R2 is what? 2 ohm. I2 is what? 1 ampere, same as I total. So this one will be 2 volt. Okay, then if they ask for V3 equal to what? R3 times I3. Okay, so R3 is what? 3 ohm. I3 is what? 1 ampere also. Okay, because all equal to 1 ampere, the total, sorry, in this case. So 3 volt. These three, if you add together, you will see it's actually equal to 6 volt. It's equal to V total. Total voltage from the battery. Okay, so that is for series circuit. Then if it's purely parallel, okay, purely parallel will be like this. Okay, 1 ohm, 2 ohm, 3 ohm. So same thing like I total, battery's voltage will give you maybe 6 volt. This one I1, I2, I3. Okay, so same thing, now you need the relationship, but this one is different. This one is actually opposite. I1 plus I2 plus I3 equal to I total. Why? Because same thing, current is like people. Right, 10 people come out, reach here, or 3 room, 3 paths. So some will walk here, some will walk here, some will walk here. Right, so the number of people that walk the first path, second path, and third path all add together is equal to the total number of people that come out from the battery. Right, so it's a sum equal to total. Then V1, V2, V3, the energy, what is the relationship? It's actually equal. V1 equal to V2 equal to V3 equal to V total. Why? Very simple. If you are one of the people that walk the first path, you only use the energy given by the battery to climb this mountain. Right? So the V1 is equal to the V total.
I can't hear anything.
You use it to climb the first mountain. Okay, if you
I can't hear anything.
Sorry? Huh? You cannot hear anything?
I can hear.
Then is your sound there in your computer.
I can't hear anything.
Your sound in your computer, the rest all can hear. The rest can hear, right?
Yeah.
Okay.
Wait, after I look at my camera.
Wait.
You check.
I got braces already.
Pain, right?
Hurt so much, dude. Oh my god, I hate it.
Hey, ready? Stop talking.
Yeah.
Then mute your microphone and keep talking.
Okay, Ken.
Okay, can? Okay, so anyway, this one just now I go through with you. I'll just quickly go through it ready first. Okay. Okay, so voltage V1 equal to V2 equal to V3 equal to V total, because the energy, remember, if you choose the first path, you only climb this mountain. So the energy you get from the battery will only be climbing this mountain. So therefore V1 equal to V total. Right, then if you choose the second path, you only climb the mountain here, then you go back to battery already, right? So the V2 equal to the energy given by the battery, which is V total. Then same thing, like if you choose the third path, you only climb this mountain here. So the V3 equal to V total. Okay, so this relationship, once you can understand, you can establish, then the rest will be easy. So if they ask for V, V1, V2, or V3, very simple. If you know this rule, it's actually all equal to V total, which is 6 volt. So if they ask for V1, V2, V3, don't even have to calculate, just take the value. That's the answer already. Right? Then if they ask for I1, I2, I3, after you know your V, you can find I already, because I equal to what? V over R. So I1 equal to V1 over R1. V1 is what? 6 volt, same as V total. R1 is what? 1 ohm. So divide, you get 6 ampere. I2 equal to what? V2 over R2. So V2, 6 volt. R2, 2 ohm. So 6 over 2, 3 ampere. I3 equal to what? V3 over R3. V3 is what? Equal to V total. So 6 volt. R3, 3 ohm from here. Okay, so divide, you get 2 ampere. Okay, these three, if you add together, you will notice is equal to 11 ampere. It's actually equal to I total also. Okay, but alternatively, you can also find I total directly. I total equal to what? V total over R total. V total is what? 6 volt. R total, how to find? Remember, for parallel circuit, you have to use a 1 over RT method. So 1 RT equal to 1 over 1 plus 1 over 2 plus 1 over 3. Right? Then lowest common multiple for the bottom, times 6, times 3, times 2. The top must also do the same. Okay, then add up the top. The bottom is all 6. So 11 over 6. So your RT, flip over, remember to flip 6 over 11 ohm. Alright, so you sub in the value, you will get 6 volt over 6 over 11 ohm. Right, so the press calculator, you can easily get 11 ampere. So it's the same answer. Okay, so this is for purely series and parallel. Ready? Okay. Ready? Okay.
Yes, yes.
Okay, can. So this one you take down first or just print your screen. Okay, now the good thing about this is you can record, you can print your screen or whatever.
What? Oh,
Okay, can. Ready? Okay. Ready? Okay, yeah. This one okay?
Yeah.
Okay, so this one okay later on. I think because you joined a bit late, I need to go to the next part, which is combine. So you can actually try your calculation worksheet 1 and the calculation worksheet 3. Calculation worksheet 3 will be purely series and purely parallel. But this one take down first. Okay, ready? Write off already. Ready? Ready?
Yeah, can.
Okay.
Yeah.
Okay, now for those of you doing electricity, okay, I'll go through the last part, which is the combine, parallel, and series. Okay.
What did you later? Go down with you.
By the way, when you all do your question, you can mark yourself all these I1, I2, I3. Right? Sometimes the diagram will mark for you and you can mark yourself. Okay, don't need to keep your diagram very clean. Okay, so this is an example of a mixture of series and parallel. You can see this and here is series, but here and here is parallel. Okay, whether this one is before or after, it makes no difference. It's the same idea. Okay, so how to solve this kind? Usually, if your school got teach combined series and parallel, usually it's the hardest already. Okay, they usually for lower set they won't teach much more complicated than this one. Okay, so if you know how to solve this, basically you're safe. Okay, in fact, upper set your electricity also will be safer. Okay, you know how to calculate if you do physics. Okay, so first thing, same thing. We need to establish a relationship. Okay, how to establish? Okay, here.
Yes.
Okay. All right. So how to establish a relationship? Okay. The idea, same thing. Remember, imagine current is like people. Okay. Imagine current is like people. So basically, now. Remember, total current is like total number of people. So imagine if you have 10 people come out from battery, right? All the 10 people reach this mountain, have to climb this mountain, right? So therefore, I1 is equal to I total also, right? After that, they reach here, got intersection. Some walk here, some walk here, right? So therefore, I2 plus I3 equal to I total. Okay, so this is the relationship about current you can establish. Okay, next, voltage. Okay, so voltage is like energy. Remember, you are one of the people, right? One of the person. You get 6 watt energy from the battery. You walk. Then you use some of the energy to climb this mountain. Okay, after that, really, I'm very noisy. Like. I mute you first. Okay, so you walk. Then you use some of the energy to climb this mountain. After that, okay, you either walk the top mountain or bottom mountain. So if you walk the top, then you climb this mountain also. So you use the remaining energy to climb this mountain. So therefore, V1 plus V2 is equal to V total, right? Then, if you choose the bottom, then you use the remaining energy to climb the bottom mountain, which is V3. So your V1 plus V3 is also equal to V total. All right, and since all of the people have to climb the first mountain, so all of them use up the V1, the same amount. So your V2 and V3 left is also equal. Correct? Because parallel. Okay, so that's the relationship. Right? After you can establish this relationship, then easier to calculate. So first, you need to calculate usually is I total. If they ask I1, it's the same as I total. So I total is equal to what? V total over R total. V total is what? 6 volt. R total, how to find? Remember in effective resistance we got learned. This here, you have to do this 2 first. So you can let it be 1 over RA first. So 1 over RA equal to half plus half. So you get 1. 1 don't need to flip, it's still 1, but remember to flip with other value. So RA equal to 1 ohm. Then these two combined, you have to add the outside one to get the total resistance. So RT is equal to 1 ohm plus the 3 ohm outside. So you get 4 ohm, right? So this one is actually equal to 6 over 4, right? So you get 1.5 ampere. So this is also equal to I1. So whether they ask you I1 or I total, it's the same answer. After you find I1, then you can find V1, okay? You need to find V1, then you can find V2, V3, or I2, I3, okay? I1, how to find? Very simple. V equal to Ri. So V1 equal to R1 times I1. So R1 is 3 ohm. I1 equal to I total, 1.5 ampere. So these times together, you get 4.5 volt. Right? After you get V1, you can find V2 and V3 already, because V2 equal to V3, which is equal to what? V total minus V1. Right? V2 equal to V total minus V1. V3 also V total minus V1. Right? So which is equal to 6 volt minus 4.5 volt. So you get 1.5 volt. So that means V2, V3, both are 1.5. Okay, then what is your I2? I equal to V over R. So I2 equal to V2 over R2. V2, 1.5. R2, 2. So divide 0.75 ampere. I3 equal to V3 over R3. V3, 1.5. R3, 2. So divide also 0.75. But not necessarily always 0.75, because if these two values different, it will not be the same. Okay, so this is actually for combined. Okay, combined, series, and parallel. Okay, which is technically speaking the hardest you will get for lower set, and upper set actually also quite common if you learn physics. Okay. Sarah, okay? Sarah, okay? If you answer, you need to unmute your microphone. Otherwise, you can tap there. Sarah, okay? Okay, can. Then, ready, okay?
Yeah.
Okay. Katia, okay? Katia?
Yeah.
Can. So same thing, this one, take note, okay? You can try to solve the question in calculation worksheet 1 for involving this one also, okay? Then if you cannot, same thing, just type the question there, then I will just explain the question on the board. Okay. So far, you all got any question or not? Only Ken Kai got asked. Chloe?
Not really.
Chloe, you got any question?
Huh?
You got any question or not?
Not really.
Okay, you done until worksheet 1 already?
I'm doing worksheet 3 now.
Okay,
I'm doing Microsoft Word.
Okay, hold on. Need to write down what you all done. Today is this is what date? Remember, in between, if between classes, if you all got the questions, you can send the question to the SLAM, the SLAM number.
Yeah.
Okay. And then remember, you all got 2 FOC online lessons that you all can book for April. So you want to book, you can actually contact the admin number, and they'll book for you. You just let them know what day and what time you're available, then you'll check for you. Okay, so now I want to check one by one first. So Ken Kai, you got any other questions? Ken Kai?
Yes.
You got any questions?
No.
No. By the way, the heat, I only put transfer of heat. You got test effect of heat or not?
I think so.
Okay, then I put one more worksheet for effect of heat for you also. Okay. Then, okay, let me see. Sarah. Katia. Okay, Sarah, you did until which worksheet already?
I'm still at the worksheet 1.
Calculation worksheet 1, is it? Or standard worksheet 1?
Worksheet 1.
At the top got right. Calculation worksheet or standard worksheet?
Calculation.
Calculation, okay, can. You continue that one, then more calculation will be worksheet 3. I also got upload the worksheet 2 lah. Then, but you can, I think you can do worksheet 3 finish, and worksheet, the calculation worksheet 1 finish, then you can try the standard worksheet 1 first. Okay.
What's her name?
Okay, then Katia, you're doing?
I just finished standard worksheet 1.
Finish standard worksheet 1. You check answer, got question, same thing, can ask. If
Okay.
not yet class, you can just take a picture and put inside the slam and say question 1, don't know how, can already.
Okay, can.
Okay, then the calculation worksheet you can try also lah.
Yeah, okay.
And I think most likely I may put one more standard worksheet if don't have yet. I think I got put it. Ready? You done which one already?
IGCSE.
Sorry? Ready?
IGCSE.
Sorry? Can't hear you.
IGCSE.
Yeah, correct. No. You are doing which worksheet?
1.
Calculation or standard?
Calculation.
Calculation worksheet. So you can try that one. Standard worksheet 1 also can do lah. Then the calculation worksheet 3 is purely series and parallel. You can also try that. Okay, then next one is Chloe. You're doing force worksheet 3, right?
Yeah.
Force worksheet 3. Okay, then same thing, answers. You check already, got question can ask. Then now you're doing energy lah, but energy you already have the materials.
Yeah.
Okay, can. So maybe I see what more worksheet for energy or force worksheet. Okay, then okay, Corinne, now you're doing
Model worksheet 1.
model worksheet 1.
Yeah.
Okay. By the way, your school got do the atoms and molecules already, or not? Because that time you say haven't yet. Okay. But that one I'll upload already anyway. Okay, then Arthur?
What?
You are doing what worksheet?
Force and pressure.
Okay, force and
The
pressure.
worksheet 1.
Okay. I think maybe I upload more force and pressure worksheet.
My booty. Yeah,
Okay,
that's
can.
what
1, 2, 3, 4.
I
Okay, so
That is very nice, right?
Sarah, your background noise a lot. Who is talking there?
I don't.
Okay, so y'all got any questions for today so far?
No.
Okay,
No.
no. If no, we will end the lesson. We'll continue next week. So again, like I said, well, online tuition, I cannot see y'all exactly, so y'all have to be self-disciplined, especially next week. After Wednesday onwards, all is even no more school already. So y'all have to be even more self-disciplined. Although no me exam lah, but if everything you forget already, then end of the year also very hard to catch up. Okay, so don't too lay back during this 1 month period. Okay, whatever need to do, still must do. Okay, then again, like I said, we have a lot of things like SLAM, you can ask questions. Then 2 FOC online, you can book. Okay, also to ask question, also to got new topic want to teach, also can let us know. Then wherever teacher conducting, also teach the topic one. Okay, Ken. So, okay, no question.
No question.
Okay, no question. We'll end the meeting. All right. Okay. See you all next week.
Okay.
Bye.
Bye.
Bye.